So the first thing you want to do is you want to make sure you have OpenAI and TickToken installed as Python packages. If you don't know how to do that, then I'll include the commands in the description. The second thing you want to do is you want to make sure you have billing set up. So in order to set up billing, you go onto the OpenAPI page and then you go Manage Account and Billing on the left side. If you don't set up your billing, then it will actually give you an error when you try to call the API. Now, if you have a fresh account, then I think it gives you $5 worth of token credits, and those token credits expire in 3 months. But once you have all of this set up, you go to API keys, you create a new key, and make sure you write it down and keep it safe, because you only get to see your key once, and if you lose it, then you'll have to get rid of it and generate a new one. So you copy your key and then you paste it onto line 6 in the script. Once you have it done, you should be good to go to actually give some prompts and give it a try. Our code is pretty simple. The code just runs inside of a while loop, and it keeps on reading user input, and if the user input is exit, then it just breaks the loop and stops. Now, the actual interesting part here is on line 50, because this is when we make the API call. The API call has 2 mandatory required parameters, right? So the first one is this model parameter, which is just a string that takes the ID of which model you want to use. Now, there are older models like DaVinci, but those ones are less powerful and they're actually more expensive than the GPT model. The second one is a very important parameter. This one is the message list. Now, the way that this works is every time a user gives an input, it doesn't only send that input to the API. It actually sends the entire conversation to the API, right? So your message list is an array with the whole context of it, with all of the user inputs and all of the responses from ChatGPT. If you go up here, we can see an example of how it would look. This is the message list, and it's an array of dictionaries. Each dictionary has 2 keys. The first one is a role key, and the second one is a content key. And the role key could either be system, user, or system. And the content is just whatever you send to ChatGPT, right? So it usually starts out with a system dictionary like this, and that's the instruction that you send to the system on how it should behave. Now, in our case, we just have a very simple one saying that you're a helpful assistant, but later I'll show you one where we instruct it with very specific things on how to write a structured essay. And then afterwards, whenever a user gives an input, you're supposed to store it here, and whenever you get a response, you're supposed to add it to the message list. That way, every time you call the API, it has the full context of your conversation. This part is pretty straightforward. Every time the user gives us an input, we just add it into the message list with the appropriate structure, which is we give it a key of role and a key of content, and we set the role to user and content to whatever the user typed. So now that we have the updated message list, what you want to do is you want to calculate the total number of tokens in the entire message list. The reason why is because every time you make an API call, there is a hard limit of 4,096 tokens that you can have in your prompt and in your completion. So prompt plus completion has to be less than 4,096. If you exceed that, then it'll actually give you an error. So the way that we calculate it is we use this function that is provided to us on the OpenAI cookbook, and we just pass the entire array of message lists in it, and it'll go through it element by element, find the number of tokens in each element, and then sum it up and return it. And once you have that, then you can calculate how many completion tokens you're allowed to have. We put that as a parameter on line 60. So that way, every time we do call the API, it never exceeds the number of tokens that it's allowed to return. Now we can actually go and give it a test run. I'll give it a very simple prompt like that. And as you can see, our entire message list with the system instruction and our new user content would sum up to 23 prompt tokens, and it's properly calculated that we have 4,072 completion tokens available. Now, the body of the response is like that. So first you get an array of choices. And the number of choices you can actually specify using this n parameter here. If I set it to 5, then it would give me 5 choices instead of 1. Now, in this choices array, you have a very important thing, which is this message key. And this message key, it contains the dictionary that needs to be appended to your message list, right? Because this is the assistant's response. And again, it's your responsibility to keep track of all the messages in the current conversation. So what we do is on line 69, we actually go ahead and we extract this choices 0 messages. We extract this entire thing, and then we append it back into our message list once we get the response from the API call. And then we go ahead and we print a label just to make things clearer, and we print the entire body. Now, the other things you want to pay attention to is it also gives you this structure here, which is it just gives you a bunch of your token usage information, which is useful to keep track of as well. So after you make that first sample API call, this is what you would have in your message list. You would have the original system, the system instruction, and then you would also have your user input, which is give me a greeting, and then you would have the assistant response, which is hello, how can I assist you today? And the subsequent API calls, you would send this new and updated message list to ChatGPT. So now we're going to go down and we're going to make the response look a lot nicer by just extracting the message, printing out some of this usage information, and we can also go and give it a much better prompt. So this prompt right here would be the essay writing prompt, and all it says is that you are an essay generator. You'll be instructed to write short essays. The tone of your writing is suitable for an academic and professional environment. Each essay will consist of 4 paragraphs. Each paragraph will consist of at least 4 sentences, but a maximum of 6 sentences. The first paragraph will be an introduction, and the final paragraph will be a conclusion. Do not label the paragraphs. And the reason why we're doing this is so that I can go ahead and demonstrate these other more technical parameters like presence penalty, frequency penalty, and temperature and top P. So we can first take a look at the stop parameter. And the stop parameter is just an array of 4 sequences. You can put any sequence in there. The idea is that as the model generates, if it ever hits one of these sequences, then it stops and returns. So I did a small example here, which is I told it to generate all the numbers from 1 to 99. And it doesn't actually do that because it just goes up to 9. It can't generate 10, so it returns. When you take a look at the documentation for presence penalty, it shows you that it's a number between -2 and +2. So +2 means that it's the most likely to talk about new topics and less likely to repeat old topics. And -2 is the opposite of that. And the default value for this is 0. So I've gone ahead and generated this essay with a presence penalty of 0, and you can pause the video and take a look at what a default essay looks like. And these are the essays with the minimum and maximum presence penalty. The minimum is -2, and if you take a close look at it, then you can see that it does in fact sort of repeat itself and talk about the same topics over and over again. But with +2, you can see that almost every sentence has a new topic. Now, if you're generating long pieces of text where your reader might be very sensitive to repetition, then it's better to have a higher presence penalty. But at the same time, it's good if your writing has some sort of structure, and a little bit of repetition is necessary for that. So the default presence penalty actually works pretty well. Frequency penalty is also a number that goes from -2 to +2. Now, if you set it to the maximum of +2, then what it does is it's the most likely to use new words, right? So the text that you generate will have the highest variety of words. But if you have -2, then it's actually more likely to take the existing words that it's already generated and then keep on using those. So here we have two example essays of frequency penalty. So on the left side we have the minimum value, and on the right side we have the maximum. Now, with the minimum, what it's supposed to do is it's supposed to discourage the model from using new words and encourage it to use words that have already been used. And in this case, it really messes it up, right? So I think what happened here is it saw that to was a word that has been used a lot of times, so it just decided to generate the rest of the essay with the word to. Now, on the right side, it does the opposite. So it's more likely to use new words and a lot less likely to repeat words that have already been used. And what if you take a close look at it, then it sort of looks like somebody went in through this essay and replaced every single word using a thesaurus. So it's pretty unreadable, and it just isn't a great way to generate long pieces of text. Just for reference, this is the essay with a default setting of 0. So the final parameter I'm going to cover is temperature, and temperature is numbered between 0 and 2. When you have it at the maximum of 2, then it tries to make your output more random. But if you have it at a lower number, then your output is more consistent and it's more focused, right? So top P is a similar idea, but I might make another video for that. Top P uses something called nucleus sampling, and in practice you really only want to be changing one of these, and it's probably easier to just change the temperature. So to test out temperature, I gave it a prompt to generate some greetings from an alien, and as you can see with 0 and 1, these are pretty normal. But with 2, the text does get very random. So now that we've covered most of the important ones, we still have 2 more left. The first one is stream, and stream is a boolean that can either be true or false. If you set it to true, then what you can do is you can actually receive your response in pieces, so you won't have to wait for the entire thing to be generated. You can just receive it as the tokens are being generated, kind of like how when you talk to the actual chatbot on ChatGPT, it doesn't wait for the entire thing, it just sends it to you piece by piece, right? The other one is logit bias, and logit bias, this might take a long time to explain, so I won't go into it in full detail. But what it is just, it's a map of where the keys are tokens and the values are just numbers from -100 to +100. And what you can do is you can adjust the bias for each logit in the model before it's sampled. And this is more complicated, but you can use it to do things like reduce the likelihood of that certain tokens are selected. And I might have to make an entire video just explaining this. And that's pretty much all.